Yeah, most of you got there with this first question. Yeah, what it means is we've got 3 times x, 3x times 3x times 3x. And what we actually realise is we've actually also got here effectively 3 cubed times x cubed, which is 3 cubed is 27, x cubed is 3. So we can keep the parts separate. Okay, so that's the first part of using algebra with it. Let's think about I'm going to go through the rules that we should have. So this one is actually a distributive function. Number 2, distributive means that the 3 spreads out across all the parts inside. That's distributive. So let's go for a couple of the easier ones. So let's try 12x squared multiplied by 2x cubed. So we look at those, and we can do the same as we did in this one. Look at the parts to do with the numbers. If there's a bracket, that distributes. If not, look at the two numbers, and we've got 12 times 2, 24, x squared times x cubed. We need to think. So let's just break it into 2 parts, just as a thought bubble. So we've got 12 times 2, and we've got x squared times x cubed. We remember our rules. X squared is xx, x cubed is xxx. So we get 24 x to the 5. And that's the distributive one. So a to the m times a to the n is a to the m plus n. What did Andre say? Is it different to what I said? No, there you go. That's it. We've got the same thing. Yeah? And that's the rule we are applying. We're applying that basic rule of indices. Notice we must have the same base. Okay. So we'll come on down. Look, what's that zooming? So number 3. Do quite a quick one on this. Third one, just to be horrible, let's do 9y cubed divided by 3y squared, which also could be written as a fraction. And I'm going to put a little note in there which is really important when you get at higher levels. At this point it doesn't matter, but you lot I expect to move on. So I'll introduce the idea to you sometime in this, what's happening. Look at the number parts. Number part is 9 divided by 3. And the algebra part, we've got y cubed over y squared. So we've got a y divided by a y, and the y's cancel. We're left with 1y. So this gives us 3y. Now, I'm going to give you one little rule though. This denominator, which value of denominator is a problem for us? What should that never be? I've asked this question in computer science to you all before as well. Remember when we were doing the errors? Yeah, it can't be 0. And that's actually got an important fact for us in this, that this statement is only true if y is not equal to 0. Okay? You can only make this simplification of 9y cubed over 3y squared equals 3y if y is not equal to 0. Right? I'm not going to ask you to put that into all of them, but it's something to keep in mind when we move into higher levels of mathematics. What this means is you could actually draw a graph of what this function does Well, it looks like 3y, but if you try putting 0 in, you're going to get 0 divided by 0, which you can't do. So we can actually use this to graph this function. And it is a line that goes at 3, gradient 3, but we're not allowed to say what happens at 0. That's the implication of that. Okay? We get what's called a hole. It's a number we can't say what's happening. If you've heard of asymptotes, it's a similar idea. The lines where you can't go. Let's go for a bit more of a complex one. It's going to be quite horrible with this one, and it's got horrible square roots in it. So let's go for 12. Y. Yeah, let's go for y to the 4 first. Square root it and divide by 2y. That's a reasonably hard one. We'll have a think. Now, similar to what we've done before, separate it out. So the square root is over the 12 and over the 4, y to the 4. So square root of 12 over 2. Now, I'm fairly certain, oh no, we haven't done surds, have we? I should have done surds before we did this. There's 2 parts to the square root of 12. So I'll take the bubble off. And what we're actually saying there is, what multiplication sum gives me 12? Where you can do a square root of something. So what are the factors of 12? 1 and 12, 2 and 6, 3 and 4. Now 2 of those numbers I can square root. I can square root 1 and I can square root 4. So I'm going to turn this into 3 times 4 and divide by 2. Yeah? I can do the square root of the 4. Okay? So when I square root the 4, I get 2. And divide by 2 again. So we're going to cancel the 2's. So this part is actually some number called the square root of 3. That's the number part. Yeah? So I can do the square root of 3, and then I do the y part, y to the 4 over y. Separate it out, and we've got y cubed. Right. So this is for the very last ones. I don't think you've got a square root of a number anywhere else. No, so this is for the very last ones that you need this sort of fact. One last one, which has got some horrible bits in it. Number 5. Let's do 10 x cubed y squared. Divide that by the square root of x. Leave the y outside. Each part of the multiplication, deal with it separately. So we got the number 10. That stays the same. No change. Look at my x cubed. And I'm going to divide by square root of x. From yesterday, what can I rewrite the square root of x as?
X to the power of 1/2.
Yeah. So if I'm dividing, What can I do to those two numbers? What do I do with those two numbers?
Take away 1/2 from 3.
Which is 2.5. Anyone know how to write 2.5 as a fraction?
25 over 10. No, 25 over 1.
Not 25 over 1. 25 over 10 does work, but there's a nicer one.
250 over 100.
What if I was to double this? I get 5 over 2. Improper fractions are nice things when we get to indices. So this is where we use improper fractions. So the x part goes to x is 5 over 2. So this could be written, if we remember our brackets, x and then to the power of a half. What's the power of a half mean? It's the square root back here. So we could actually write that as the square root of x to the 5. And we're left with y squared over y cancels down to just y. So we've got 3 bits that we're going to bring together, and we get 10, the square root x 5, and y on the end. Okay? Strictly speaking, yes, I cannot have the square root of x cannot be equal to 0, y cannot be equal to 0, which says x cannot be 0. That's a strict thing. This is the exceptional part again. So that's just a side thought. But if you can make the bottom 0 in any way, that value is not allowed. Okay, there's an exercise I've put together. It's in the textbook on page 66. I've also made a copy of it and put it onto the lesson. So go away, have a work at them. The answer book's been attached as well. There's a pile of questions for you. That's the questions. Okay, so I suggest skip the first section. I think you can all do that without a breeze. Maybe one column from the second one. Maybe a column, or maybe column for the first 3 and have a go at the bottom 3. And then one column in the bottom section. And question 41 and 42, if you get a simplified answer for that, showing a method, because I've given you the answer book, you must show some steps along the way, then I will give yellow tickets out. Okay guys, so if you're happy with what you're doing, flash your microphones. I'm not expecting to say much more unless somebody comes back to me for questions sort of 41, 42. They're the only 2 I think are really horrible. Question 29 would be a good one for everyone to do though. I'd like to see 29. Okay. Question 30, possibly. But don't spend too long in these early ones. I think you can do those ones down to there without much problem. Some of these, be a little bit more careful and try and do some of the harder questions. We're looking for challenge. Okay. I have given you a document you can paste back into any work you want. So Yakov, Linara, no. What happened to Linara? Linara telling me she's the one who sent me an email. Sorry, I'm channeling to myself.